Hello, welcome to Pluralsight and to this course on Linux Systems Programming. I'm Dr. Chris Brown and this module is called Controlling Access, Identity and Permissions. And in this module I want to look at the two sides of the access control story. First of all, we're going to look at the idea of user and process identity. And then we'll have a look at the ownerships and permissions that are attached to the files and other resources in the system. So, as I say, we'll look at user identity. We'll see how to search and enumerate the list of user accounts. We'll look at the idea of process identity and in particular the important distinction between the real and effective identity of a process. And we'll talk about the file permissions and ownerships. Remember, all of this is through the eyes of a systems programmer. Now, I don't want to go over what is probably very familiar to you, but I'm using here a line from the password file just to remind ourselves of what a user account actually consists of. It has a username, an encrypted password, or a hashed password rather, which is not stored here. Historically it was, but it's elsewhere these days. The user has a numeric user ID, which is important. For example, the ownership of a file is stored in terms of the numeric user ID of the owner. The user has a primary group. The primary group ID is often numerically equal to the user ID, but it certainly doesn't have to be. This field is historically known as the GCOS field. It's a somewhat free format field. Some administrators use it to store the user's full name or telephone number or things like that. Then we have the user's home directory and the user's choice of shell. Now, from a systems programming point of view, a more relevant way of looking at this is through the password structure, which looks like this. And as we scan down the list of members here, you'll see that they actually map one-to-one onto the fields of the password file that we just looked at. Now, account information can be stored in one of several places. So if we want to look up something within this account database, a program calls a routine known as a resolver. And it's really these resolvers that I'm trying to get around to talking about. The resolvers in turn consult a configuration file, nsswitch.conf, the name service switch file. And this file tells the resolvers where to go to look for the information that they need. In this case, it might direct them to the local file, like etc password, or it might direct them to an LDAP directory, or maybe to one of the older NIS maps, or possibly to several such places. Now, if this was a system administration course, we'd spend some time here looking at the nsswitch.conf file. But it isn't, it's a systems programming course. And as programmers, we simply need to be grateful for the fact that the resolvers and the name service switch file sort it all out for us. The point is that wherever the user account information is stored, we actually query it in the same way. So let's take a look at a couple of these resolvers, getPWNAM and getPWUID. The difference is that getPWNAM looks a user up by name, getPWUID looks them up based on their numeric user ID. Both of them return a pointer to a password structure that we just looked at. And as you can probably guess, if they can't find the user, they will return a null pointer. The third resolver here is getPWEnt. Now this is useful if you want to step through the list of accounts one by one. In fact, it's usually used in a loop. Each time you call it, you get the next account from the database. It returns again a pointer to a password struct, and it will return a null pointer when it's reached the end of the list. Finally, we have set pwent, which basically rewinds the list so that we could start stepping through it again if we wanted to. So let's take a look at a little program that actually steps through the user accounts. What it does is it lists those accounts which has a user ID greater than or equal to 1,000. Now the exciting line here is this one I've highlighted. This is one of those classic perform, assign and test idioms that are so popular in C. Here we're calling get pwent in a loop. We're looping as long as it doesn't return a null pointer, and we're assigning that pointer to u, which is a pointer to a password structure. We reference off that pointer to get the numeric user ID, and if it's greater than or equal to 1,000, again we reference off the pointer to get and print out the name of that user account. There's a very similar set of resolvers for querying group information, traditionally stored in etc. group. These are getGrNam and getGrUID. GetGrNam does the lookup based on the group name. GetGrUID looks it up based on the numeric group ID. Both of them return a pointer to a group structure, which I'll show you in a moment. And again, as you can probably guess, they will return a null pointer if the lookup fails. And then, as you can probably guess by analogy, we have getGrEnt, which is used for enumerating the groups. It allows you to step through the groups one by one. Each time you call it, it returns the next group structure or pointer to it from the group list. So it's usually used in a loop, and it returns null when it's reached the end of the list. And finally there we have setGrEnt, which basically rewinds us back to the beginning of the list of groups. So what does the group structure look like? Well, here it is. It basically parallels the fields of the etc. group file. We have the group name, the group password, which I don't think anybody uses these days, the numeric group ID, and then finally a list of group members. I know this char star star data type tends to put some people off. Basically, if you think of it as being a list of strings, that's really what it is. It's a list of strings naming the users who are members of that group. Now I have a little program here for your entertainment. It's an attempt to mimic the standard system program called ID. And I thought I might start by running the original system program. This is not my code, this is the standard tool. And you'll see that what ID does is it prints out my numeric user ID and also my username. It prints out my primary group ID and group name, and then it prints out a list of the groups of which I am a member. Now I'll leave that up there on the right hand side so that we've got some idea what we're actually aiming for here with this program, and let's have a look at my code. So we begin with a few variable declarations for the user ID, the group ID, the pointer to the password structure and the group structure, and so on. So the first question is, how do we figure out which user ID we're dealing with? Well, it's the user ID that this process is running with. And we'll talk about this a little bit more formally in the next part of the lesson, but getUID will return the user ID of a running process, which we basically just print out there. So that gets us, if you look over in the right hand window, that gets us that part of the output. We then call getPWUID to map that numeric user ID back onto a username, which we print out here. So moving over to the right, that gets us this piece of the output. We then do the same thing for our group, looking at the group ID of the process there and printing it out, mapping it back to a group name and printing that out. Very similar piece of code. So that gets us this piece of the output over on the right. Let's scroll down and look at the rest of the code. It gets a little bit harder here because we actually have to, in order to find out our group memberships, we have to list the entire group database and find the ones that we're actually a member of. So here we're looping over all of the groups. Here we're looping over the group members of that group. Now this is one of those wonderful bits of pointery stuff that is so wonderful in C, but basically what we're doing is we're stepping over the list of group member names of this group. And if that name matches the name of the user that we're dealing with here, then we print out the group ID and the group name of that group, because that group has me as a member. Okay, well, we will save the program and we will compile it. We'll call it My ID to keep it distinct from the original ID program. Okay, and we'll run it. And there's the output. Well, we've actually got a reasonable approximation to the original program. There are a couple of differences. For a start, the original ID program lists my primary group membership twice, once here and then once again in my list of group memberships. My version doesn't do that. I always thought that that was a strange bit of behaviour of the original ID program anyway. The other thing, of course, is I've got this spurious trailing comma here. And frankly, I can't really be bothered to add the logic necessary to get rid of that. But we've got a fairly good approximation to the original program, and this is a good example of the use of resolvers to do lookups and to enumerate the account databases.